Hi everyone, how are you all? Hope you have an amazing day today. Welcome back to the ongoing chapter, Relations and Functions. Uh, nice to see you. People are waiting for today's lecture, today's topic. Students, this topic uh, is binary operation, the next topic of this chapter, next and last topic of this chapter. And this topic also not in syllabus, but we will discuss its key points, its definitions, its theory, so that in case we need, whenever we need, we can solve the questions comfortably, isn't it? So, because many times what happens that the question that comes that is asked becomes easy to solve when you know certain things. So that's why we are making a discussion on this binary operation, right? So after discussing the definitions, we shall see some questions also of binary operation. Uh, Binary. What do you mean by binary? Have you heard of binary? Uh, Bi means what? In computer science, mathematics, pi means 2, isn't it? Operations means you apply certain functions, certain operation. For example, addition operation, right? Addition, and generally for yes 2. And generally for applying addition, for example, if I talk about addition, then to apply addition, or how many quantities you apply addition, right? 2 quantities, right? For example, 2 plus 5. Same way subtraction also, or division also, or multiplication also. You need input 2 quantities, right? And when you do addition, the final outcome is how much? The final outcome is 7. So finally you get 1 quantity. So this makes it base to define a binary operation in a proper manner. Right, let's begin with the definition of binary operation. So, to define a binary operation, we need to work on a certain set. Let A is a non-empty set. Right, I have excluded that case when A is empty. Let A is a non-empty set. Any operation, let us assign some name to it. Let it be star. An operation star is said to be binary operation. Only if it is a function. You can say in this manner also that a binary operation is nothing but a function from a function. Instead is star, and because it is function, so it will have a certain domain and a certain codomain. So its domain is it works from A cross A to A, right? So finally, what is binary operation? Binary operation is a function actually. And function means all our definitions, previous definitions and concepts will be applied. So binary operation is a function which works from A cross A and gives the final outcome in A. Right? We need to understand the meaning of this definition. Why A cross A is taken as domain? Because for example addition. When you apply addition, you need 2 quantities. Right? Actually, right? 2 plus 5 equals 7. This is the same thing if I write plus operation applied on the order 12 to 5 and I got the result 7. Right? So So as input, I need two numbers. I need two elements, and two elements means I need ordered pair, right? And where ordered pairs I'll get ordered pairs in certain Cartesian products. So that's why A cross C. And in the codomain, why I've taken A? Because as a result, I don't get two numbers. I get a single number, right? I get a single number, and that's why the codomain is A. So binary operation is what? Binary operation is a function which works from A cross A to A. And here there is a notable fact that the codomain is A. The final outcome must belong to A. We can mention it because this is very important, that a binary operation defined on a set A, defined on a set A follows closure. Set A follows closure law. Right. The meaning is that capital A's set is closed with respect to star. With respect to star. Right. Some examples will clear this this sentence. That what do I mean to say actually? For example, 1 plus or addition is a binary operation on n. Naturals. Why? Because you take any two naturals and you add them, and finally you will get a natural number. Right? So final outcome lies within n. That's why n is closed. We can say n is closed, and that's why plus or addition is a binary operation on n. Another example, let us see that subtraction is not a binary operation on n, because you take two natural numbers and you subtract them, and the resultant will not be always the member of set of naturals. Right? I show you an example. Because 2 minus 5 if you do, then you get minus 3, and this doesn't belong to n. Right? So if the resultant goes outside set A, then that operation is not binary operation. Binary operation means the final result should always lie within the parent set, the set on which the operation is defined. But if I take z minus subtraction is a binary operation on z, isn't it? Because you take any two integers, you subtract them, and finally the resultant number will be an integer. Either you do 2 minus 5 or you do 5 minus 2. The resultant will be an integer, right? Either positive or negative. That's why subtraction is a binary operation on integer. Let us see some more examples. What about multiplication? Will it be? Check, say yes or no. Multiplication is a binary operation on n, and I think on z as well. Like, okay. What about division? ठीक है, yes बोला. ये नहीं पता कि multiplication के लिए बोला कि division के लिए बोला. डिवीजन के बारे में भी पूछ रहा हूँ. What about this division? Is it a binary operation? Is a binary operation on n? Say yes or no. Division is a binary operation on n. You divide n into natural numbers. Finally, you get a natural number always. Is it so? No. 2 divided by 3. No. No. Yes. 2 divided by 3. Is it a natural number? No. If the resultant is not the member of the same set, that is not a binary. Say yes. You cannot say yes. Division is a binary operation. Example number 6. And tell me, check it, analyze it, and then you write the answer. Division is a binary operation. It's not a binary operation on n. Division is a binary operation on R. Tell yes or no. You divide any two reals and you get whether or not you get a real number. बताइए. Yes बोल रहे हैं. चंचल, वेदपाल, अमन, हुसैन, सौम्या, देवांशी. Yes. अंजलि. बहुत तेजी से आंसर्स आ रहे हैं शिखा. ऐसा है क्या? 2 यस. कोई नो नहीं बोल रहा है. बिल्कुल मेजॉरिटी के साथ सरकार बन रही है. अच्छी बात है. बट मुझे ये आर में सब लोग कोऑपरेटिव नहीं है. इस आर में एक 0 भी है, यू नो. और 0 से डिवाइड करेंगे तो क्या रियल नंबर आएगा? आपके तालाब में एक भी मछली खराब है तो हम बोलेंगे नो. अगर हम इसको बाइनरी डिक्लेयर कर रहे हैं, then you take any two real numbers and the division should be finally a real number. तो अगर मैं कह रहा हूँ ये 0 यहाँ पर एक फैक्टर है, यहाँ पे एक है, 2 divided by 0 doesn't belong to 1. Yes. तो हटाए. This मैं आपके लिए छोड़ रहा हूँ. This is not a binary operation. This statement is wrong. Division is a binary operation on R and 0 is excluded from it. And this I'm leaving for you to judge and analyze whether this is a binary operation or not. Right? This is my conjecture. I am just predicting that it may be a binary operation. Right? You just need to ensure whether divide any two non-zero real numbers and final outcome will always be a non-zero real number. Yes or no? Decide and then tell me afterwards. Right? तो इस तरह के बहुत सारे और तमाम एग्जांपल्स भी सिर्फ एडिशन की थोड़ी है. हम कोई दूसरा सेट ले लेंगे तो हम नंबर्स पे बात कर रहे हैं. हमारा पेरेंट सेट ऑफ मैट्रिसेस हो सकता है. वहां पे ऑपरेशन कैन बी एडिशन ऑफ मैट्रिसेस, डिवीजन ऑफ मल्टीप्लिकेशन ऑफ मैट्रिसेस हो सकता है. राइट? सो further more examples can be tried. Right? Now let us see. So this was the definition. Very important for binary operation. Very, very important definition. Now, the next thing in this topic is properties of binary operation. Very easy. बहुत आसान है. आपने पहले भी सुनी होगी क्लास 10 में probably. एक बार फिर से यहाँ पे बात कर सकते हैं. Properties of binary operation. The very first one is closure law. Of course, let star be a binary operation on any set A. Then closure law. That A is closed with respect to star. क्लोजर लॉ का मीनिंग क्या है वो हमने मैंने ही इस पे बात कर ली है अभी जस्ट नाउ, राइट। कि बाइनरी ऑपरेशन की पहली प्रॉपर्टी है कि द final outcome lies within the same set on which the binary operation is applied, isn't it? The next property is associative law, and this you must have heard of. Associative law, right? Say there are three numbers A, B, C in the set capital A, and the binary operation is star, and you apply star on A and B, and then the resultant you do star with C, and this is same as you first you apply B star C, and then you take A star with the result, right? Means without changing the position, you can group them in any manner. A, B can be taken together, or B and C can be taken together. And note that I have not changed the position, right? A was on first place, B was on second, and C was on third place, and so it is in the right side. So this is what associative law, and you must have seen that this is true for addition binary operation. May not be true for every binary operation, but sometimes it is. Next, that identity element. ये आपने पहले भी ये बात सुनी होगी कि फॉर एग्जांपल अगर मैं एडिशन की बात करूं तो जीरो का एक स्पेसिफिक बिहेवियर है. You do 2 plus 0 and you get 2. You get minus 10 plus 0 and you get minus 10, etc. etc. तो जीरो की क्या प्रॉपर्टी है? It gets absorbed. When you operate any number with 0 and add any number with 0, you get the same number, and 0 gets, you can say, dissolved, right? So this is the property of identity. Be not necessarily addition, be it any other binary operation. E belongs to A, of course, is said to be identity element. Identity element if A star E is equal to E star A is equal to A, and very important, for every small a belongs to capital A. And let me write and close it within the box and keep it like that. Right. So E is said to be identity element if E you operate with any element of capital A, say small A star E you do, or E star A you do, finally you should get A, right? For each and every element of capital A, then E is said to be identity. So E should have a property to get absorbed in any other element with respect to star. This is what the identity element. For example, 0 is identity element in R with respect to addition operation, isn't it? And you know what? If the operation is multiplication, what should be the identity? I'm leaving for you. Put in live chat. On set of natural, what should be multiplicative identity? Because is it also 1? They want to get right. Correct. Check to get good. And one more property, inverse element. इसको भी हम एक एग्जांपल से समझने की कोशिश करते हैं कि एडिशन की बात कर लेते हैं, ठीक है? एडिशन. Suppose there is any element 2. In 2, what you add so that you get the additive identity, which is 0. Can you make a guess? वन सभी ने बोल दिया, बहुत शानदार, बहुत अच्छे। मैं ये कह रहा हूँ कि is there any some element is there two, what I minus 2, right? What should I add so that I get additive identity, which is equal, of course, minus 2, isn't it? And here we say minus 2 is additive inverse of 2. Conversely also we say that 2 is additive inverse of minus 2, right? So you know, to understand that, let A is any element in capital A. B belongs to A is said to be inverse of A if what happens? A star B equals to B star A, and what you get? You should get identity is equal to identity element, right? And that means write it clearly where E is identity element. Right. B is said to be inverse of A, and conversely, if A star B is equal to B star A is equal to identity element, right? Inverse may not exist for necessarily for all the elements, right? Sometimes may exist, sometimes may not exist, right? For example, one more example, if I see multiplication, if I take instead of real numbers, if I take, right? Multiplicative identity, many of you have told 1. So in 2, what should I multiply so that I get 1? 1 by 2. दिखा दीजिए 1 by 2, ठीक है। हम क्या बोलेंगे कि 1 by 2, 1 by 2, राइट? 1 by 2। अब हम बोलेंगे 1 by 2 is inverse. So 1 by 2, no, and it will be equal to 1 by 2 into 2 also, right? Full definition is being specified. 1 by 2 is inverse of 2, right? Of course, with respect to multiplication operation, right? So we discussed the inverse element. Now one more property, and that property is said to be commutative law or commutative property. This also you must have heard in previous classes. Commutative property means that you do either A star B or you do B star A, the resultant should be same, both should be equal. So it will happen in case of addition, in case of multiplication, subtraction, right? तो जरूरी नहीं कि हर बाइनरी ऑपरेशन कम्यूटेटिव प्रॉपर्टी को satisfy ही करे. Subtraction is a binary operation in Z, but doesn't satisfy this operation, this law, this property, commutative property. ठीक है? तो ये हर बाइनरी ऑपरेशन प्रॉपर्टीज फॉलो नहीं करती, लेकिन कोई कोई करती है। थोड़ा क्लोजर लॉ तो मैंडेटरी करती है, isn't it? ठीक है। अब कुछ और सम नोट्स हैं, उसके बाद हम इस टॉपिक को यहाँ पर कंक्लूड करेंगे। सब क्वेश्चंस विल सी। और शॉर्ट में कि there's some certain names are there that A together with the binary operation, if the binary operation star is said to be an algebraic structure, right? There's a name of algebraic structure. We write like this: A with a star is called an algebraic structure. One more thing, that A with some binary operation star satisfying first 4 properties First four means commutative log छोड़ के. Then it is said to be a group. Said to be a group. है ना? Commutative log भी अगर satisfy करता है, A star satisfying all the properties means that also if it satisfies, then if then it is said to be an abelian group. Right? That is said to be an abelian group. Now, let us see some questions based on this binary operation. Let's have a look. I request you all to see your NCERT book, exercise 1.4. Randomly, because the exercise is easy, cannot going to solve all the questions, but some questions we certainly will discuss. Let's have a look. Determine, first question says, determine whether or not each of the definition of star given following is a binary operation. Right, for example, A star B is equal to A minus B, and the set is important. What is the set? On Z plus. Can you see plus sign? Plus है कि नहीं? Yes, it is. Positive integers की बात हो रही. Positive integers means naturals, isn't it? So, what do you say? बच्चों से पूछ लेते. No. Okay. Write the example. Right. Write your answer. Binary or not? Not binary operation. Because 2 लिया, 5 लिया, but 2 minus 5 doesn't belong to Z plus, isn't it? Okay, perfect logic. Yes, बिल्कुल इस तरह से लिखना. और कोई ले लेते हैं, for example, second part can you answer? Part number भी लिख देना है ना. मैं guess लोगों में confusion हो मुझे चेक करने आपकी बात. Second part is on Z plus A star B is equal to AB. On Z plus. बोलो. Part number लिख के आंसर लिखो, ठीक है? So that I can check. बोलो फटाफट. Second part yes. Part number नहीं लिखा. Part number लिख के आंसर लिखो फटाफट. अच्छा, अच्छी बात है. Yes, all people are saying yes. Right, very good. Because you multiply any two integers and the final outcome will be an integer, right? इसमें कोई confusion नहीं है, doubt नहीं है. Easy है. To it yours only. Fourth part, let us see. Fourth part is A star B is equal to modulus of A minus B, and this is also on Z plus. What you say? What about fourth part? Binary? Nisha Kumari is saying 2. 2, yes, no, yes. Second part, yes. Fourth, yes. Binary, right? You take subtract any two integers and you take the modulus, of course. Positive. You subtract any two positive integers and you take modulus. Finally, it has to be a positive integer. Yes, fourth part is certainly a binary. Yes, it is binary. Yes, it is binary. लेकिन ये पूरी बात आपको सिर्फली y और n से काम नहीं चलेगा. लॉजिक देना है, ठीक है? Let us see question number 2. So please do solve all the parts. Very easy there. Question number 2. They are asking for each of the following operations given below, determine whether the star operation is binary, commutative, or associative. ये तीनों बातें मुझे चेक करनी है. Let's check Second question, let's check whether binary or not, associative or not, uncommutative or not. Second question, on Z, A star B is equal to A minus B. Binary or not, difference of two integers will always be an integer. Write your answer, Petri. Difference of two integers will always be an integer, is it? Not. No. Yes. Right. Aman and Pragya Rawat is right. That yes, it is binary. Yes. Binary it is. Isn't it? Okay. Then check whether it is commutative. Is it? 2 minus 5 is same as 5 minus 2? Is it? No. Not commutative. Correct. What about associativity? Associativity means, you remember the definition of associativity. Associativity says A star B star C is same as A star B star C. That to apply associative property, you need to have three numbers, right? And without changing their position, you can group them in any manner. This is what associative property says. इसमें क्या है? फटाक से चेक कर लीजिए थ्री नंबर्स लेके क्या मेरा प्रेडिक्शन तो कहता है कि ये नहीं होगा, बाकी मैं आपके लिए छोड़ रहा हूं। ठीक है, fraction of second it will take to judge that this is certainly not associative. Not associative. Not associated. देखो अंजलि ने कहा, सब बोल रहे हैं, very good, very nice. तो क्या ये अपेक्षा करना बहुत ज्यादा होगा कि बाकी सारे पार्ट्स आप खुद से ट्राई करेंगे और उनके आंसर मुझे बताएंगे? जरूर बताएंगे. गुड. कुछ के आंसर अभी बता दो तो मुझे अच्छा लगेगा. थर्ड पार्ट, राइट? तैयार हो जाइए, आंसर सब निकाल लीजिए. मुझे तीनों बातें चेक करनी है, whether it is binary or not, commutative or not, associative or not. Third part, it is A star B equal to AB by 2. And the set is what? Rationals. Rationals. Binary it is. बोलो फटाफट पार्ट नंबर ले आंसर लिखा. Binary it is. And whether associative it is, and whether commutative it is. Ankit Singh is replying that third one, yes, binary. Very good, Ankit. Yes, it is binary. Then both commutative, yes, commutative and associative. तीनों ही है. Very nice. I think it is commutative because AB by 2 is same as BA by 2. Okay. So A star B same as B star A. So it is commutative. Or for associativity, A star B star C will be equal to A star B star C will be BC by 2, isn't it? And this will be A multiplied with BC by 2 whole by 2. And finally it will be ABC by 4, isn't it? And which, if you find A star B star C, that also will come same. It will be AB by 2 star C, and this will be AB by 2 into C whole by 2, which is ABC whole upon 4, and they both will be equal. So yes, associative. Yes, it is associative. Isn't it? Correct? Very interesting parts of the next parts, but I'm leaving for you people to find out whether or not this is associative. Right. Now, let's take a look on question number 3 of exercise 1.4. All the parts which I am giving for you must be solved by you in your notebook. Third question is, consider the binary operation on the set 1, 2, 3, 4, 5 and given by, this is minimum of A and B. Right? Okay. Write the operation table for this operation. So, operation table means when the set is very small, the capital A set is 1, 2, 3, 4, 5. Very nice. Many people have given the answer for previous question. Very good from my side. So, operation table means that you make a table. Horizontally, you write the elements of this set. Vertically, also you write the elements of this set. And then what you do? You make all combinations. Isn't it? Like 1, 1, 1, 2, 1, 3, 2, 2, 2, 3, 3, 2, etc., etc., etc. And apply this operation and write the resultant number here. Right? And then finally the table that you get is called as operation table. So shall we do 1 and 1 minimum is 1, 1 and 2 minimum is 1, 1 and 3 minimum is 1, etc. Similarly, 2 and 1 the minimum is 1, 3 and 1 the minimum is 1 and 1 and 1. 2, 2 the minimum is 2, 2, 3 the minimum is 2, 3, 2 minimum is 2, 4, 2 minimum is 2, 2, right? 3, 3 minimum is 3, etc., etc. Please complete this table, and this table finally is called as operation table, right? And after that, question number 4 comes. Let's have a look. Question number 4. One table is given, and they are asking you to compute 2 star 3 star 4. Right? From the table, you can see the answer. In the question is giving an outline. It is drawn in your book. You can see, and they are asking, this is what? This is how much? So 2 star 3 you can find out from the table. How much? I can see it is 1. And this becomes 1 star 4, and 1 star 4 also you can find out from the table. And this is 1. Right? And this is. Then, like similarly, the other part also can be solved. Or first part. Then second part they are asking that is a star commutative. Commutative means, this is question 4 I am talking about, right? Don't get confused. Commutative means that you take either 2 star 3 or you take 3 star 2. They should be same thing. And in one word, if I say rows and columns should be same, should be identical. Right? If you remember, in matrices we discussed the concept of transpose of matrix. So if you take the transpose of this table, you should get the same table. Then this is what? This is commutative. The operation will be commutative. So you can check whether this operation given, the table given in this question is symmetric or not. Right? Rows and columns are identical or not. You can check, and accordingly you can write your answer that this is commutative, isn't it? Right. Further, more questions are there in which you have to check the commutativity, associativity. In some questions, you find out identity, element. Rest of the questions, you please give a try. Of course, some more questions of this exercise we shall discuss in next lecture. Apart from that, we shall discuss some more questions based on previous topics. Miscellaneous questions we shall discuss in next lecture. Thank you so much. Thank you very much for watching. Complete your work. Writing is essential. You understand everything and you don't write. will not be productive at all in the end. Right. So please write everything, because writing is important. That too, 100% solving 100% questions is very important, at least from NCERT book. Rest all I'm leaving for you to judge, decide, and to get confident. Thank you.